Okay, this is our Calculus AB test through indefinite integrals preview. And this first problem we looked at during class a little bit yesterday. I'm just going to write these down really quickly. Determine we have the derivative function g of x is shown. Actually, it should be g prime of x is shown. It says g of x, g prime of x. That's g prime of x is shown. The graph consists of semicircle plus 3 line segments. Here we have the semicircle and we have 3 line segments. Determine the intervals where g of x is decreasing. Well, any place that we have critical numbers, and I was counseled to set up one of these number lines. The critical numbers, and for the critical numbers we're going to put g prime on top and g on the bottom. And the critical numbers are going to be here at -5, -1, and at 3. I think that's all of them. And we have g prime is negative between -8 and -5. And so the function is decreasing, and it's also negative between -5 and -1. Function is decreasing, and also decreasing between -1 and 3. And lastly, to the right of 3, greater than 3, we are increasing. So, function is decreasing on, I'm going to put just -8, comma -5. We did conclude yesterday that you actually could span the entire interval from -8 to 3, I believe. Because even these places where the graph of g prime touches would not disqualify that from being the function for being decreasing all the way. Okay, to 3. Okay, so anyway, that's what's going to be. All relative extrema. Well, the only relative extrema will be right here at x equals 3, because g prime changes from negative to positive. So I think graphically the number line demonstrates that's going to be a relative minimum. Okay, concave down. So for concavity we need to have another number line analysis, and we have g double prime here and g below, and the critical numbers for concavity are going to be possible points of inflection -5, -1, and also +1. And so here we have the slope of g prime is increasing, so we say plus concave up. The slope, oh, I forgot something, right? What about -3? That's a good catch. Okay, we have negative here, so concave down, positive here, negative between -1 and 1, concave down, and concave up for x greater than 1. Okay. So concave down would be simply -5, -3, union, and -1, 1. Term values where g of x has a POI, point of inflection, will be when concavity changes. So for x equals, I'm going to make a set notation, -5, is one answer. Negative 3. Negative 1. Negative 1. Positive 1. I think that's all of them. I think we have 4 points of inflection. 1, 2, 3, 4. Yes. Okay, determine g double prime of negative 6. Well, that's going to be the slope. So we go to negative 6, and we see the slope of this is 1. So answer is 1. Determine from negative 1 to 3 g prime of x dx. That's simply going to be between negative 1 and 3, the area of this guy right here, but below the x-axis negative. So that's going to be negative 1/2. That's a triangle. 1/2 base. The base is 4 times the height is 2. So 2 over 2 cancel. So our answer is negative 4. And if we change this and went from, let's say we went from negative 1 to negative 5, let's change this to negative 5. Erase the negative 5. Excuse me. We're going to have this area here, but we're going negative, but this is below, so it's going to be positive area of this semicircle. Okay, we got to get on with the rest of this. Find the integral of each of the following. Problem 2. Well, for this one, I have a and b. For a, we're going to separate this out. We're going to have 6 times x squared dx minus 6 times x dx plus 2 x to the negative 2 power dx. And so going ahead and working this out, we're going to have 6 over x to the 3rd power raising. We're going to divide by 3 minus, we're going to have 6 x squared divided by 2 and plus 2, we're going to have x to the, we take negative 2 plus 1, x to the negative 1 power, we're going to divide by negative 1. So that's going to give us, actually I forgot this, didn't I, plus c. That's going to give us 2x cubed minus 3x squared minus 2x to the negative 1, so it'll be minus 2 over x plus c. So that's going to be our answer to part A. Okay, part B. We're going to have, similarly, we're going to go ahead and take, we're going to rewrite this in what I call calculus-friendly form. We're going to have 2 times, we're going to have, that's going to be x to the 2/3 power dx, right? Because x squared, but this is to the 1/3 power. So we're going to have to take 2/3 plus 1, which is going to equal 5/3. So our answer is going to be 2x to the 5/3 divided by 5/3 plus c. And we're going to have, we can rewrite this, and we're going to have 2 x to the 5/3 is going to be cube root of x to the 5th. And dividing by 5/3 is the same as multiplying by 3/5 plus c. And so we're going to get 2 times 3 divided by 5 is going to be 6/5. I'll leave myself a little room below here. 6/5 cube root of x to the 5th power plus c. Dividing by a fraction is the same as multiplying by its reciprocal. That's where we get 5/3 here, 3/5 over here. Okay, next one. Find a particular solution to the following differential equation. We have dy dx equals x plus square root of x if the graph of y passes through 4, 2. Let's go ahead. The first thing we're going to do is separate the variables. And to do that, we're going to multiply both sides of this equation by dx. So we have dy is equal to x dx plus, I'm going to take this, I'm going to say x to the 1/2 power dx. Okay, so that's the separation of variables in a free response AP Calculus test. You'll get 1 point for that probably. Next thing we're going to do is integrate both sides of this, which means all terms here. So we're going to get y on the left side equals the integral of x dx is going to be x squared over 2 plus, we're going to have x to the 3 halves divided by 3 halves plus c. Give myself room. I'm going to work over the right. We're going to get y equals 1/2 x squared, and we're going to get plus x to the 3 halves. That's going to be square root of x cubed, and we're dividing by 3 halves, so we're going to multiply by 2/3 plus c. And so now we're just going to substitute in here, if y passes through 4, 2, what is the particular solution? We're going to substitute here. I'm going to go below and leave a gap above. So we're going to put, let's see, y is 2 equals 1/2. We have 4 squared plus square root of 4 to the 3rd power. Let's see, 4 to the 3rd power, 4 times 4, that's going to be 64, right? So we're going to have 2, oh, plus c, don't forget the plus c. We're going to have 2 equals 1/2 times 4 squared. That's going to be 1/2 of 16, which is 8. And then we have the square root of 4 cubed. 4 cubed is 64. So plus 8 plus c. So we have 2 equals 16 plus c. If we subtract 16 from both sides, we get c equals -14. So our particular solution, I'm going to put here in purple, is y equals 1/2 x squared plus square root of x cubed minus 14. This is our particular solution. Okay. Next, Find the absolute extrema and where they exist on the graph of g of x equals x squared minus 3x plus 2 on the interval, closed interval, negative 2 to 2. We're going to use our candidates test. Before that, we're going to just go ahead and see if we have a critical number between this interval negative 2 to 2. So I'm going to put g prime of x is equal to 2x minus 3. And to find our critical number, we set this g prime of x equals 0. 0 equals 2x minus 3. And so we have 2x equals 3. So we have x equals 3 over 2. And we check, and 3 over 2 is in that interval. So if we drew out a number line, we'd start here at between negative 2 and 2, and then we would have 3 halves, which is 1.5, right over here. And so we could take, well, we would know that would have to be, we would just have to find out what they are. And so we'd have a candidates test. Our candidates test is going to be our endpoints. So we have x, y. We're going to have negative 2 as a candidate for an extrema. 3 over 2, since 3 over 2 is a critical number. And if we would further, we should just go ahead and put g prime and then g. Well, to the left, if we put in 0, say, we're going to get negative. So we're going to be going down to the left. And then to the right, if we put in a number bigger than 3 halves, say 2, we would get positive. So that's positive. So we're going up here. So this would be a candidate for in fact, it is going to be an absolute. That's going to be our absolute minimum for this range, and then 2 here. Okay, so we just have to plug in to find that. So we got to use g now. G of 3 halves is going to equal to 3 halves squared minus 3 times 3 halves plus 2. And so we're going to get 9/4 minus 9 halves we're going to put C there, plus 2. Okay, 9/4 minus 9 halves, that's actually going to be negative 9/4. So it's going to be equal to negative 9/4 plus 2, which is 8/4, right? 2 is 8/4. We're going to get negative 1/4. So negative 1/4, this is going to be an extrema. Okay, it's going to be, we're going to call this the absolute. It's going to be relative. It's going to be also absolute minimum. We know that. And this is a parabola here. So our maximum is going to be farther away. So for our maximum, we need to plug in negative 2. You see that? This 2 is very close. It's only 1/2 away. The negative 2. So we're going to say g of negative 2 is going to be negative 2 squared minus 3 times negative 2 plus 2. So we're going to get 4 negative plus 6 plus 2, which equals 12. So 12 would be this would be our absolute max. And so these would be our answers right here, 12 and 1/4. And actually the point, that would be it. If we plugged in 2, we would get bigger than negative 1/4, but smaller than 12. That'd be pretty easy to see. If we just made this positive, see, made this positive, we get 4. 4 minus 6 plus 2, we would get 0. Okay, so anyway, that's our answer. That's number 4 worked out. Number 5, let h prime of x equals quantity x plus 2 times quantity 2x minus 1 represent the derivative of h of x. Determine where h of x is increasing, justify. Well, to do that, we can go ahead and create a number line. What are the critical numbers? Well, x equals negative 2. You see that as a critical number? You should. And then if we solve this one here, if we put 2x minus 1 equals 0, we're going to have x equals 1/2. So 1/2 is another critical number. Okay, and then we can put h prime here, and we'll put h down below, and we're going to go ahead and take to the left, using this function, use a number less than negative 2, maybe negative 10. That's going to be a negative times a negative, which is positive. If we take a number between negative 2 and 1/2, we're going to get maybe 0. If we plug in 0, we'll get 2 times negative 1. We'll get negative. That's a negative here. And then to the right, we're going to get, if we use 1, say we get positive times positive. So let's see. Determine where h of x is increasing. Okay, increasing on negative infinity all the way to negative 2, and union 1/2 comma positive infinity. Okay, good. Determine where h of x is concave up. Well, for that, we're going to have to do some more analysis. I'm going to try to figure that out by multiplying through on this. We could use the product rule, but what we're going to have is that h prime of x equals 2x squared. We're going to have plus 4x here minus x, so we're going to get plus 3x, and we're going to get minus 2. So that's h of x. So h double prime of x is going to be 4x plus 3. And so for concavity, we set this equal to 0. So 0 equals 4x plus 3. So x is going to be equal to negative 3 over 4. Am I right? I think I'm right. So that's going to be our point of concavity, or critical number of concavity. So I'm going to just make a number line right up here, blue. And I'm going to put negative 3/4 down here. That's negative 3/4. And this is going to be h double prime above and h below. And to the left, set this to 0. If we set, let's say we're going to find less than 0. Well, let's set this to 0 to do right. If we set this to 0, we're going to have positive, right? We're going to have concave up. And if we set this thing at, say, negative 1, we're going to have negative, concave down. So concave up on negative 3/4, comma, to infinity, and justify because because h double prime of x is positive. Okay, if 0, 2 is a point on h of x, find h of x. Well, we're going to take this h prime of x, which we solved for here. Okay, what it is that h of x is going to be equal to the integral of h prime of x dx, which is going to be equal to, okay, 2x squared plus 3x minus 2 dx. So I'll leave myself a little room here. We're going to say is equal to 2 times x squared dx plus 3x dx minus 2 dx. And that's going to be equal to x cubed over 2. Let's see, and that's going to be 2 times x cubed over 2, right? Plus 3, we're going to have x squared over 2, and I made a mistake over here. I hope you caught it. I put over 2 here. It's going to be over 3. And minus 2x, isn't it? Yes. Minus 2x plus c. And so if we go ahead and plug in, we have if 0, 2, let's say this is going to be, we'll say 3, that's 2, 2, 2. 2 equals 0 plus 0 minus 0 plus c. So 2 equals c. So h of x is going to be simply, okay, h of x is going to be equal to 2/3 x cubed plus 3/2 x squared minus 2x plus 2. So that will be h of x. Okay, next problem. Problem 6. Let f of x and f prime of x be differentiable for all real numbers. The table gives values of f of x and f prime of x on the closed interval from -2 to 4. Estimate f double prime of 3. Well, f double prime, that's going to be like f of x is position, f prime of x is velocity, f double prime is acceleration. So that'll be the first derivative of this. So to find, estimate f prime of x, we're going to use that f of b minus f of a over b minus a. So the slope, we're going to say f double prime, we're going to say estimate of x equals f prime of b minus f prime of a all over b minus a. And so f prime of b, and we're going to use, we've got to use it 3, so we're going to use either side. We're going to take 4 as our b and 2 as our a. So f prime, double prime of x, now remember this is an estimate. I'm going to put estimate here, minus estimate. Okay, b is 4, I'll say b equals 4, a equals 2. So we're going to have 4 minus 2 in the denominator, and f of, we need f prime, right? So we're going to have negative 6, that's b, put in parentheses, minus, oh, let's see, negative 2. So we have negative 6 minus negative 2 is going to be negative 4 over 4 minus 2 is 2. So negative 2 is going to be our answer. And that's going to be estimated f double prime of x of 3. F double prime of 3. I'll put 3 here. I'll put x down here. I'll put 3. All right. Write the equations of tangent normalized to the graph of f of x where x equals negative 1. Well, at x equals negative 1, we'll call this the slope of the tangent line is going to be just a value. So we go to x equals negative 1, and that's going to be f prime, that's f, m of t is 2, and m sub n, which is going to be our negative reciprocal, is going to be negative 1/2. So negative 1/2 is the slope of the normal line, 2 is the slope of the tangent line, and we need the point where x equals negative 1. So our point's going to be negative 1, comma, negative 3. Right? Plug that in. So we're going to have our tangent line equation is going to be this one right here, y minus negative 3, so y plus 3 equals 2 times x minus x1, x minus negative 1 is plus 1. So that's going to be our tangent. That's going to be tangent. And this other one, the normal one's going to be the same thing. Y plus 3 equals, now we're going to put negative 1/2 times quantity x plus 1. Okay, this is going to be a normal line. So these are our two equations for the tangent and normal line respectively. If f prime of x has only 1, 0 in the interval from negative 2 to 4, where's the graph of f of x increasing? Justify. Well, we can go ahead and take a number line to do that. Take a number line right below. I know I'm getting into the other writing. We'll do that. Well, our 0, or our critical number, is at negative 1, right? It only has 1, 0. And so here we have f prime of x above, f of x below, and this is all positive over here to the left of negative 1. So you have the function going up from where is it? From negative 2 to negative 1, and f prime is negative there, so we're going down. So we'll say where the graph is increasing, we're going to say negative 2 to 1. Right, that's our 0 at 1. 1, because f prime of x is positive. Say greater than 0. Okay? 7. The velocity in feet per second of a particle moving along a horizontal line is given by v of t equals t squared minus 9, where t is greater than or equal to 0, and t is given in seconds. Term of velocity at t equals 4 seconds. And velocity is the particle moving right up. Okay, this is our velocity. So we just need to find the velocity. We just put in v of 4. It's going to be 4 squared, right? T is 4, minus 9, which equals 16 minus 9, which equals 7. We're moving along feet per second. So we'll say feet per second. Okay, and we'll say moving right. Moving right is positive, right? Moving right. Because v of t is greater than 0. Okay, determine where the particle changes direction. We'll do that. We need to take the velocity. We just need to set this velocity equal to 0. So we'll say 0 equals t squared minus 9. And factoring, that's going to be equal to t plus 3 times 20 t minus 3. And we see that the velocity will change direction where t equals negative 3 and also at t equals 3. But we're only interested in greater than or equal to 0. So we're not interested in this negative 3. So 3, we'll say determine where the particle change direction at t equals 3 seconds. And I haven't even proved that yet, really, have I? To do that for certain, let's make a number line here at 3. And we're going to put v of t here. And we're going to put position here. We'll put x of t, position below. And if we go to we have our function here. If we take a number less than, say, number 0, well, if we plug in 0, which way are we going? Well, if we plug in 0, we get a negative number. So we're moving to the left here between 0 and 3, and we put in a number bigger than 3, let's say 4. Well, we already determined from part A that that's going to be positive. So this verifies so that t equals 3 seconds because the sign of velocity changes from negative to positive. Determine the equation for acceleration at any given time t. Well, acceleration is going to be the double prime. So a of t equals v prime of t, which equals 2t. Is that right? I think that's right. For any given time t. So v prime of t, a of t equals 2t. That's what it is. I don't think there's anything wrong there. So that's going to be our answer. Okay, and then part D, is the particle speed increasing or decreasing at t equals 4 seconds? Well, at 4 seconds, we have our, at t equals 4, v of t is positive, and if we plug in 4 for t here to this acceleration, and v prime of t is also positive, so we have the same sign, so therefore a speed having the same sign is increasing. Okay, let's try to go on to 8. Okay, fine. We have the limit as x approaches infinity of 2x cubed minus 2 over 4x to the 4th plus 5x squared. Well, this is going to be a situation where we have x to the 3rd power on top and an x to the 4th power. So as we go toward infinity, this 1 on the top is going to go to 0 in comparison to the 1 on the bottom. So our limit, our horizontal asymptote, is going to be 0. So y equals 0. That'd be our horizontal asymptote. Okay, the limit as x approaches infinity of 2x plus 5 over 6 minus 9x. Well, we have x to the first power here and here. So we're going to have our coefficients. We'll have 2 over negative 9, which simplifying is going to be negative 2/9. So that's the horizontal asymptote is going to be y equals negative 2/9. Okay? Box this one in here. And over here, limit as x approaches 2 of x squared minus 5x plus 6 over x squared minus 7x plus 10. We're going to substitute in 2 to both these equations, the numerator and the denominator, both these expressions. So we're going to have the numerator 2 squared minus 5 times 2 plus 6 over 2 squared minus 7 times 2 plus 10. And we're going to have 4 minus 10 plus 6. We're going to get 0 in the numerator. And here in the denominator, we get 4 minus 14, which is negative 10, plus 10, 0. So let's try. So we have more work to do. Let's factor this. So limit as x approaches 2 of all this is going to be limit as x approaches 2 of factoring. We're going to get x minus 2 and x minus 2 above and below as factors. In the top, we're going to get x minus 3. And the bottom, we're going to get x minus 5. And so these things will cancel. So what we have to do is plug in 2. So we're going to get the numerator 2 minus 3 over 2 minus 5. Is that right? Yes, 2 minus 3 is going to be negative 1. And 2 minus 5 is negative 3. So we're going to get 1/3. That is going to be our limit as x approaches to all this. Next, go on to 9. Find the limit as h approaches 0 of all this here. Definition of a derivative. Our function, we'll just call it f of x, is going to be, let's see, 10 x to the 9th power. Now this one here is a little confusing because we have a radical form here, right? We got a rational form over here, but they are the same. So what we're going to get is we're going to have minus 2x to the 1/3 power. So that's going to be f of x. And so to find the limit as h approaches 0, we need to take f prime of x. So f prime of x is going to be 9 times 10. That'll be 90 x to the 8th power. Is that right? Minus 2 times 1/3, and we're going to have x to the negative 2/3 power. And so that's going to 90 x to the 8th. We're going to have negative 2/3 x to the negative 2/3, which is going to be equal to 90 x to the 8th minus 2 over 3 cube root of x squared. Okay, I'll box this in here. Okay. Now the last one, 10. 0 to 3, from 3 to 0 is going to be a negative 3 dx. What that looks like is this. Try to draw a more or less horizontal line here. Okay, it looks a little better. Okay. So we have negative 3 dx. I'm going to draw this in blue. Here we have negative 3, negative 3 right here. And we're going from 0 to 3. So x equals 0, x equals 3. So we're talking about this area in here, and that's going to be a rectangle 3 by 3. That's going to be a square, actually. So we're going to have 9. So this is going to be below the x-axis, will be negative 9, but we're going from 0 to 3, so we're going to get negative 9, which is going to be equal to 9. So equals 9. That's going to be your answer, number 10. Anyway, this does not include every twist and turn that's going to be on that test you're taking tomorrow. And there were on these exams we gave a couple twists and turns that are not going to be on there tomorrow. So overall, this should help you a lot if you follow carefully. It's all stuff in some respects that we have done. Thanks.